So, my name is KV Kishore Reddy and I am working in Cambridge Junior College. So, I am the physics faculty in this college. Today, we try to learn about the concept of capacitors. Okay, today we try to learn about the concept of capacitors. In this class, we try to learn about how to solve the circuit problems. Okay, so there are so many different circuit problems come in various competitive examinations. So among that circuit problems in the today's class, we'll see some few circuit problems. In that circuit problems, how we have to solve that circuit problems, we can see in this class. We already know about what is the meaning of the parallel plate capacitor. Okay, and regarding this parallel plate capacitor, in this class we try to solve some circuit problems. Okay, let us see about this circuit problems. Suppose, for example, in one application, if they mention that let us consider three capacitors. This is the first capacitance whose capacitance is C1. Let us consider this is the second capacitor whose capacitance is C2. Let us consider this is the third capacitor whose capacitance is C3. Now, if you see this combination, clearly it appears that these three capacitors are connected in series. Okay, since they are connected side by side and one of the negatively charged plate is connected to the positively charged plate and so on. Okay, so that this combination looks like to you these three are connected in series. So easily we can say the equivalent capacitance of this combination is 1 by C1 plus 1 by C2 plus 1 by C3. Now, if the same problem, if it is given like this one, let us consider a conducting wire. And if that conducting wire, if it is connected like this one, okay, then if the wires are connected like this one, and if they ask what is the equivalent capacitance of this combination, okay, as already I said to you, let us say this is the point A, let us say this is the point B. Now the question they asked is find the equivalent capacitance between A and B. Okay. Now, if they ask the equivalent capacitance between A and B, what is the preliminary step we have to do? Let us imagine one cell or battery across the ends A and B like this one. Okay. So, at which points we want to calculate the equivalent capacitance? At that point, let us imagine a cell or battery like this one. Let us say this is the positive terminal of the cell, this is the negative terminal of the cell. Here the potential is V and here the potential is 0. Okay. As already we know that if you start to resolve any circuit problem, the basic step we have to be followed is we always choose our path from the cell positive terminal. Okay. As we move from this point, this is always a conducting wire. Okay. In this conducting wire, there is no resistance is there, no capacitor is there, no inductor is there. If there is no resistor, capacitor or inductor is not there, then we can know this across this conducting wire at each and every point potential remains same. Okay, buddy. That means here in this at this point, if the potential is V across this one at each and every point, the potential becomes V. Okay. And here, so if the for this negative terminal, if you imagine the potential is 0 across this conducting wire, again we can say the potential is 0. Okay. Now let us see carefully. Here at the point A, if the potential is V, then let us see. If you move from this point A towards this one, here also the potential becomes V. Okay, since there is no resistor, no capacitor, no inductor. Let us see carefully. At this point, if the potential is V, since it is a continuous conducting wire, so that across this one also the potential remains same. So at this point, if the potential is V, then at this point also the potential again it becomes V. By means since across this conducting wire, no resistor is there, no capacitor is there, and no inductor is there. Okay. Now let us see this point also. Here the potential is 0, so that at this point also the potential becomes 0. At this point also the potential becomes 0, since it is a conducting wire. Across this conducting wire, as already we mentioned that the potential remains same. So here also the potential becomes 0. Okay. Now if you see these three capacitors across this first capacitor, the potential difference is V. Okay. The potential difference is V. Across this second capacitor also the potential difference is again it is V. Across this third capacitor also, that means across the plates of the third capacitor also the potential difference is V. Okay, but it means across the first capacitor potential difference is V, second capacitor potential difference is V, third capacitor potential difference also becomes V. That means after connecting this conducting wires, the potential across each and every capacitor remains same. If the potential difference, if it remains same, then we can say these three are connected in parallel. Okay, then these three are connected in parallel. If these three are connected in parallel, then the equivalent capacitance between A and B is, now it becomes C1 plus C2 plus C3. Since these three looks like they are connected in parallel. Okay, that means before connecting this conducting wires, these three appears that they are connected in series. But after connecting the conducting wire, these three capacitors looks like they are connected in parallel. Okay. Then what is the equivalent capacitance across these three capacitors means it becomes C1 plus C2 plus C3. Okay.